Despite months of achieving one victory after the other and fearsomely smothering Saddam Hussein's regime into the very inner cores of Baghdad, the defiant Iraqi forces refused to yield to the Western coalition, risking prolonging the violent conflict spun from the Iraqi invasion of Kuwait. The Iraqi High Command orchestrated its resistance efforts from the reinforced depths of the fortified underground bunkers, specifically designed to withstand even the most potent American bombs. With the world eagerly awaiting a resolution to the brutal conflict, the U.S. rushed to develop a new, unprecedented solution to the bunker problem. The American engineers then got to work, and within 3 weeks, came up with a bomb casing made out of pieces of an artillery gun. The weapon was so robust that it could penetrate even the most well-protected bunkers in the world. A quick solution. In early 1990, Iraqi dictator Saddam Hussein strived to acquire territories and more resources for his nation, turning his attention towards Kuwait. On August 2, 1990, Hussein sent 4 elite Republican Guard divisions and Special Operations Commandos to invade and occupy Kuwait. 5 days later, George H.W. Bush gave the green light for Operation Desert Shield and organized a coalition of 35 nations to defend the Saudis and liberate Kuwait. U.S. military planners began to analyze Iraq's defenses, and military analysts had doubts about the effectiveness of the Blue 109 penetration bomb against the Iraqi fortified structures. They wanted a quick solution to get rid of this threat. Consequently, the Air Armament Division at Eglin Air Force Base, Florida, started developing a new bomb variant with enough power to tear apart the underground Iraqi bunkers. The Bunker Buster. In January of 1991, the coalition attacked Iraq following the complete destruction of enemy radar sites during an audacious raid led by Apaches from Task Force Normandy. The USAF then ditched the laser-guided variant of the Blue 109B and started working on a new bomb labeled GBU-28 on February 1st. The bomb was built from modified 8-inch artillery barrels from M110 howitzers, as there was no time to create bomb casings from scratch. The coalition needed them as soon as possible. The prototypes were hand-filled with explosives and fitted with a new nose section, and they were ready by February 14th. Despite the urgency, financial cuts, and lack of proper research, the GBU-28s were delivered to the Air Force 2 days later. The bomb weighed over 5,000 pounds and carried over 630 pounds of high explosives. Plus, operating it was rather simple. The body of the GBU-28 was fitted with a laser-guided head and a system of stabilizing fins attached to the rear section of the casing. These additions allowed the bomb to target and reach its objectives with a high accuracy rate. Upon making contact with the ground, the GBU-28 triggered a short-delay fuse that led to detonation once it had penetrated enough ground to destroy the target. Before the U.S. military could use the novel weapon against the deep bunkers near Baghdad, it had to ensure it could achieve what was promised. Expedited testing. To correctly measure its penetrating capabilities, 2 tests were devised. One would put the bomb into an actual airdrop scenario, while the other would be launched into a 22-foot stack of steel-reinforced concrete slabs, using the legendary Holloman rocket sled track in New Mexico. The GBU-28 had to pass both tests, as it would have to penetrate over 50 feet of soil before reaching the reinforced concrete shells of the Iraqi bunkers. Only after piercing through the concrete walls would the bomb detonate, eliminating top Iraqi commanders even in their most protected fortifications. The first test was carried out on February 24, 1991, when the new Bunker Buster penetrator was mounted on an F-111. The bomb casing had previously been filled with 630 pounds of molten explosives in an excruciating process that lasted over 36 hours. The F-111 flew over the Nevada desert, and once it approached the target, it swooped down to drop the bomb. The GBU-28 hit the ground at supersonic speeds, instantly submerging itself into the ground as if it were butter. After impact, the test operator found the projectile embedded over 100 feet below the ground. The bomb had pierced so deep that extracting it was deemed too expensive, and it was left buried in place. The test was considered a resounding success. 2 days later, a second GBU-28 filled with concrete was launched horizontally from the Holloman rocket sled track facility in New Mexico. The projectile also surpassed the speed of sound as it hit a 22-foot steel reinforced concrete barrier and was found over half a mile away from the target after having pierced through all the obstacles. The results were decisive and reassuring. In less than a month, they had created an unprecedented deep penetrator weapon that was now ready to be dropped on top of Iraq's previously untouchable bunkers. Ending the storm. After the bomb's performance during testing, the weapons were immediately delivered to Saudi Arabia. Because of the urgency, the GBU-28 became the US-made operational bomb with the least test drops in history. On February 27th, 2 USAF F-111s darted across the Middle Eastern skies, armed with the 2 remaining GBU-28s. The American aircraft targeted an Iraqi military compound near Baghdad, which was believed to be harboring top Iraqi commanders. As the first F-111 dropped its payload, the penetrator missed its objective, and the aircraft withdrew with no success. However, the second projectile found its mark and pierced the bunker with devastating force. Footage recorded from the F-111 shows smoke and debris being shot out from the bunker's ventilation vents, indicating that the projectile had succeeded in piercing the buried fortification. The following day, American reconnaissance aircraft photographed the target area, and the footage revealed a large, bottomless hole carved in the top section of the Iraqi bunkers. The US officials then learned that everyone inside the bunkers had lost their lives during the attack. Consequently, Saddam Hussein signed a ceasefire, bringing Operation Desert Storm to an end. Whether it was because of the previous day's bombings, or because the conflict was already coming to an end, many experts agree that the super penetrator might have helped accelerate the process. From then on, the GBU-28 became known as the bomb that ended a war. Global use. Following the end of Operation Desert Storm, the U.S. Air Force kept improving the design of the GBU-28 bomb. Some were employed by American F-15s against the Strzeljica Command Center during the NATO bombing of Yugoslavia in 1999. Other F-15s carrying GBU-28s were used at the beginning of the 21st century during Operation Enduring Freedom in 2002 and the subsequent invasion of Iraq in 2003. In 2005, controversy arose after media outlets reported the first foreign sale of GBU-28s to Israel. Over 50 bombs were delivered in 2009 for a possible attack against Iranian nuclear facilities. Then, in 2014, the US approved selling GBU-28 bombs to South Korea, following the ongoing nuclear tests of the aggressive North Korean regime. Despite being created in less than a month, the GBU-28 became a highly valuable asset for the United States military, and immediately changed the course of modern warfare. Its success was so massive that in October of 2021, the U.S. Air Force announced it was working on the GBU-72 Advanced 5K Penetrator, a more powerful bunker-buster bomb that will improve on its predecessor's design by being built to reach bunkers buried hundreds of feet underground. Thank you for watching our video. Please like and subscribe to Dark Tech to find more exciting content about the technology employed during global conflicts. And check out the rest of our Dark Documentaries channels, where we publish regularly. Stay tuned.